This video covers how to approach Newton's second law problems when there are two objects involved. Let's work through this example. Two crates, 100 kilogram and 50 kilogram, move upward by a cable. If the system accelerates upward at 1.5 meters per second squared, what is the tension in both of the cables? So this is what it would look like. We have two blocks. The 50 kilogram one is on top and the 100 kilogram block hangs below. Both are lifted up by these two different cables, and we're looking for the tension force in both of these two different cables. So our first step to solving Newton's second law problems is to draw free body diagrams. So let's draw a free body diagram for both the 50 and 100 kilogram blocks. We know there is a tension force acting up on the 50 kilogram block. The tension force from the rope above the two blocks is the tension force that we're going to call T1. We also know that there's a weight force acting down from the 50 kilogram block, and we will call this weight 1. And there is also one more force acting on the 50 kilogram block, and this force is the downward tension force because of the 100 kilogram block being held up by the 50 kilogram block by the in-between cable. We will call this tension force, because of the second rope, tension 2. Now let's look at the forces acting on the 100 kilogram block. We know that there is an upward tension force, and the tension from the middle rope we call tension 2, and there is also a weight force acting down because of the 100 kilogram block's mass. We will call this force weight 2. The second step to solving Newton's second law problems is to write out the net force acting in the x and y direction. Since we only have forces acting in the y direction, we will just write the net forces acting in the vertical direction for the 50 and 100 kilogram blocks. Let's look at the 50 kilogram block first. If we call up positive, then we would say the net force is equal to tension 1 minus tension 2 minus weight 2, since tension 1 is pointing up and weight 1 and weight 2 are pointing in the negative directions. Now let's look at the net force acting on the 100 kilogram block. Since up is positive, we know that the net force is equal to tension 2 minus weight 2. The third step to solving Newton's second law problems is to set the net force equal to the object's mass times its acceleration. Let's first look at the 100 kilogram block, because we only have one of the unknown tension forces acting on this block. So we say that the net force, which is the second tension force minus the weight, and weight is equal to mass times acceleration due to gravity, so 10, is equal to the mass of the 100 kilogram block times its acceleration, which is 1.5 meters per second squared. When we plug in these values and solve, we see that the tension in the rope between the two blocks is 1,150 newtons. Next, let's use Newton's second law to find the tension force in the rope above the 50 kilogram block. To do this, we will use the net force acting on the 50 kilogram block and set it equal to the 50 kilograms block's mass times its acceleration. So the net forces acting on the 50 kilogram block in the y direction are T1 minus weight 1 minus tension 2. We know that the weight of the block is equal to its mass times gravity, and we already found that the tension force in the rope between the two blocks is 1,150 newtons. So we can plug in those values. All right, and then we set this equal to the object's mass, which is 50 kilograms, times its acceleration, which is 1.5 meters per second squared. And when we solve, we see that the tension above the 50 kilogram block is 1,725 newtons. So there's another way that we can approach these problems with two objects. We can simply apply Newton's second law to the entire system. So in order to find the net force acting on the entire system, we just simply add together all the force vectors drawn for all the objects in the system. So we have T1 that is positive and a weight 1 that is negative, and a T2 that is negative coming from the 50 kilogram free body diagram. And then we add the forces from the 100 kilogram free body diagram. So we have a positive T2 and a negative W2. And then we set this net force equal to the mass of the entire system multiplied by the acceleration of the entire system. What is nice about analyzing the system as a whole is that these T2 forces, we have one pointing up and one pointing down, and when we add them and then subtract them, they cancel out. All right, so we can then plug in our known variables because we know the weight of each of the blocks, and we're still looking for that tension 1. We know that the mass of the entire system is going to be the 100 kilogram plus the 50 kilogram. And when we solve, we see that the tension force is still 1,725 newtons, just like we solved in the other problem.